Good morning. So this is kind of a review. I'm sorry about the audio apparently getting broken. Thank you for a couple of people who have pointed that out. We try to do these in the lab and do them as quickly as possible, and so apparently we had some kind of an audio issue going on in our recording setup. So I apologize for that. So let's go over a loop really again. So that's one of the powerful things of any programming language and any computer. We know that computers are dumb, they can only work with zeros and ones, but this ability to write a loop is really powerful. We can have a loop that will do things over and over and over again. It's kind of the upside. As a human, we can look at a lot of different numbers, we can look at text, we can do all kinds of things, but we don't do things over and over and over very well, but a computer does. So I want to come in and take a look at a loop here, and so apologize, I'm not making up the whole screen with it. This makes it easier when I want to go in and do things. So there are two kinds of basic loops. So there is what we call a definitive loop. So in other words, if we say I want a loop that runs 5 times, we've made a definitive loop. Very common, very useful. The other type of loop that we have to have something change, and it says, all right, now I've changed, so now I can stop. So think about your thermostat as a good example of a loop. Your furnace doesn't run for a predetermined amount of time. It runs until the temperature is above your preset temp. So my furnace at the house over last week ran and ran and ran and ran and ran and ran, and it was waiting for that temperature to exceed my set point, in which case it would shut off. So I'm going to show you some of these in some other slightly different models. So please hang on. And one of the things I want to point out is in the week folder for week 5 and 6. So I put some additional pieces in there. So I put in some items that may be helpful. I use something called the Python Programming for Absolute Beginners. And then I also introduced chapter 5 of another textbook, and I'm going to drag pieces of that in and out. So there's one called chapter 5 Looping, which comes from a text. Let me drag it over and you can see it here real quick. So in this case, this text is Programming Logic and Design. And what we can look at is this idea of loops. And this is the structure of a loop if we look at it graphically. And so I'm going to use a few things out of this textbook to hopefully make it a little easier. So this is a while loop. So if we come down here and we look at a diamond is always a decision. So if the condition is true, so if whatever we're asking, if the house still needs additional heat, yes, furnace runs. Comes back around. Does the furnace still need to run? Yep. And it will loop until that while condition is no longer true. So we can also write them, and this is where it's kind of a handy tool, is this idea of something called pseudocode. In other words, you're structuring it with some text that looks like programming code, very similar, but it's written in your own language, and there's a lot of rules for it, and we won't really get into it in here, but this looks like what we're going to write. So while this condition, these things are all going to execute in that indented block, which is very much like Python. And then we have an end while. In Python, we don't require an end while, but at least in our pseudocode, it shows me exactly what's going on. So if I look at something like this program, so here we have start of our program, end of our program are always those kind of ellipsed circles here. So we declare statements. We run some function called housekeeping. We ask a question. And here we're saying, is it not end of file? In other words, if we're searching through a group of items, as long as it's not to the end of it, we're going to come back in and do some kind of task and then come back and check it. So this program is really the idea of that while loop, and it shows a little bigger program. So here's our start, here's our stop, and then while this condition is true. So the other piece with a loop, and so this maybe makes a little more sense. In this case, we want a definitive counter. So we want to print something 4 times. So again, this is in pseudocode, so it's a little different than our Python, but I hope we can make the inference here. So here we have our declarations, and in fact we set something here. We say count equals 0. And in most languages we have to say, hey, it's a numeric. Python makes our life easy, and we can just say count equals 0. Here we test our count. Is count less than 4? Well, if it is, then we come out here and we say print hello. We have a statement where we alter that loop control, count equals count plus 1, and we come back up and we run the loop again. When that loop is done, then we can output our final goodbye, and we can see that we've printed it then 4 times. So here's where we have to be a little careful. So we have to think about how the computer counts also. So sometimes I like to put in some statements, and I'm going to throw up Python really quickly, and I'm going to click up a new file just because it's a really easy way for me to demonstrate what it looks like inside of Python. So here I've just done a new file, and so I'm going to make this pretty short. I'm not going to do a lot of the details that I really should in other ones, but so I'm going to sit here, and so I'm going to say count equals 0, and then I'm just going to ask while count is less than 4, and I will say I hate hard coding variables in like that. And notice it already indents this for us, so anything that's going to happen in here, so I'm going to print hello. I also need to make sure that I use the increment here, so count equals count plus 1. And notice I don't use the shortcuts. You can do it if you're used to it. This is just my weird preference. And so we know that those are all going to run because they're indented. So then I can go back after this loop runs. Then I can do a print for goodbye. So in theory, this is going to print hello 4 times. To save it as some name here. So, trying to type and talk is always bad here. So, chunk. Run that again. And of course, it always wants to run in the other window. So I have 1, 2, 3, 4 hellos, and then it says goodbye. So it did what we thought it was going to do. Now, on the other hand, if I forget to do this increment here, and so I can simulate that I forgot that by putting in that pound sign, and you are certainly welcome to try this. I run this module, and oh my goodness, it just continues to sit here and run and run and run and run and run. Because if we don't change that value, this sentinel value we're going to call it, it's never going to meet this condition, and so it's going to run forever. Handy tip, Control C, and that will actually break that. And if you're curious, then you could do a print, and we could actually see what count is like, or any of these other things if you wanted to do it. But obviously, in here, we know that we need to make sure that that is still present. So the other issue we run into, so we say while it's less than 4, all right, and I want to go from 0 to 4. Why? It says it's less than 4 because I want count to be 4. Well, remember, we start counting with 0, and so sometimes it's even a good idea, and you can always put in things like this to say what is count, so that you can check this as you work along. And so, oh yeah, 0, 1, 2, 3. It never reaches 4. And it never reaches 4, but we have 4 iterations because our computer starts counting at 0. Now, I can force it to start at 1. Now, if I run this, you say, well, I'm going to start it. But we only get 1, 2, 3 hellos because it's not less than 4. So, and you could change that to a not less or equal. And so you just have to be aware that the computer counts at 0. We tend to count at 1. And so sometimes that causes us some stress and some anxiety about what's going on in our world around us. All right. So you are certainly welcome to look at these. So here's an indefinite loop. So similar type of structure, but we're asking, hey, should it continue? And this is actually putting it back in the user and saying, do you want to continue? And so that loop control variable still could have an ability to change. So if we do not have a way to change the loop control variable, then we end up with what's called an infinite loop. So here's another example, very similar. So here we've got some more items in there. So we've got payroll, and we're doing some functions. So I encourage you to look at this text also as a looking at it. We can actually nest these loops, which gets a little more complicated. So programmatically, if I look at it, here I have one big loop, and then inside of here I have a second loop. We do these fairly often. It takes a little bit to keep track of them. But one thing we do is we put our entire program often in a loop. So think about a game that you've played recently. When you died, it asked, hey, do I want to start over again? Yep, I do. I want to play that whole game again. And so we put the game here, and then the startup menu is in this loop here. So there's a lot of pieces to these loops. So common mistakes, and this is true no matter what language. Putting statements inside the loop that should be outside of the loop. Wrong comparisons. We forgot to alter it somehow, or we didn't initialize that loop control variable. We've used it somewhere else, because a lot of times we use the same variable over and over again for these loop control variables in our program. If we don't initialize it right before the loop, often we'll pick a value that's already existing somewhere else. So that's one of the things that we need to make sure that we do. So back to our Python book. So one of the things that it's just my own personal preference. I don't do a lot at this iterative level. I like to actually write the program and then look at it. So it looks the same except slightly different. So these would all be programmatic. So we'd say number equals 2, exponent equals 3, and each time we run through this loop, we're increasing that, so we're doing a cube. So we'll take a look at some of these examples. So count controlled loops, in other words here, the other way we can do a loop that is really, really handy in Python is using something called a for loop. Honestly, you could write every loop as a while loop if you really wanted to. For loops are really handy. And one of the things that a for loop does that's really handy is it sets it all in one piece. So I could say for count 1 to 4, I can do it as a range like this. I can actually do it this way as a range. I can search through an existing string. So there's a lot of really interesting and fun things that we can do inside of these loops. So I just wanted to give you a quick loop. And again, if we look at what's going on in these loops, one of the things that we have to be aware of that really happens in Python a lot, especially when you start out, and I'm as guilty as anybody, these are assignment operators, that equals sign. If I'm doing a comparison, I have to do a double equals. And so we'll show you an example of that and kind of look at them. So the off by 1 error, so in other words, we need to think about the logic of the computer. So in this case, here we're looking at how we can print through a range of characters. For character in that entire string, and it's going to print 1, string piece at a time. So we can also specify our ranges and different things. Loops that count down. So if we wanted to count from 10 to 0, going by -1 each time, we can. We can also format somewhat a little bit. So we will take a look at some of those. So here we have these formats. Here's where that's a little confusing. So notice those are inside of our print statement, inside the quote marks even. And these are those escape characters we talked about earlier. So we'll work on some formatting and show you some of that, but I think I'm going to do that inside of the assignment to maybe show you how to do that and make life a little easier for you there. So to format integers, letter D is used, so S or D, and it's just telling me, hey, I'm going to format this to, in this case, 12 places, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, if I counted right. So we will work on oops, that went too far there. So we can also do it with a float. So here we can use a float, and so we want to always maintain that of $100.00. We want to show it. If I don't use some kind of nomenclature, it rounds off those extra zeros. It keeps 1 to tell me that it's a float, so I can look at it really quick. In this case, I can use these escape characters here. So I put a $sign in, escape character 0.2f question. So then we can see what's going to print. Your salary is salary, and so that just says that we know that it's going to be a float. We know how long it is and what precision we want. So this one is a fairly common one you'll use, and that will format essentially like a dollar text. There's actually some other ones that you can grab that do things like a math functions that will actually, you can put into a currency format, and some others. All right, I'm going to chomp off here, and I will create some other videos, so please stay tuned, please work hard, and we will all get through this together. Thank you, everybody.